Welcome
to
DC Brushless
Motors,
Explained
Simply,
by
Haley,
Albers,
Storm,
Cooper,
and
Zane.
Fountain.
Brushless motors create a torque from a system of electromagnetic attraction and repulsion. In the stator, the outside part of the motor, coils of the wire receive current which creates magnetic fields. The Biot-Savart equation relates the direction of current to the magnetic fields it creates. This comes in handy because changing the direction of current also changes the direction of the magnetic fields, which give lots of control over the timing and direction of the magnetic fields created. These fields attract and repel the permanent magnets in the rotor, causing it to spin. It's important that the coils in the stator receive different current at different times so the rotor keeps spinning. If the current didn't change, the rotor would get stuck. Later we'll talk about how current is modulated to keep the motor spinning.
The name brushless motor implies that there is a brushed motor, and there is. Brushed motors use brushes to contact the rotor, which has the coils and conducts current through them. The permanent magnets are on the stator, which remains stationary and doesn't need current. Issues arise in brushed motors because of the friction between the brushes and the rotor, such as sparking, noise, limits to angular velocity, and ultimately the brushes wearing out after prolonged use. This is why motors, especially in older electronics, wear out.
But how is it that brushless motors work on the most basic level? Well, it's actually quite simple. The Biot-Savart law tells us that current direction determines magnetic field direction, and it also gives us a handy equation for the magnetic field of a solenoid. Looking at this, we can see that by changing the direction of the current, we can change the magnetic field outside of the solenoid, and thus we can change the force on an inner rotor that's a magnet.
As mentioned before, it's important to time the direction and magnitude of current to make sure the motor doesn't get stuck or move in an undesired way. A common configuration, and the one pictured in the diagram, is to set 6 coils 60 degrees around the stator and have 4 permanent magnets in the rotor with alternating poles. Coils across from the stator receive the same current, which matches the symmetry of the permanent magnets in the rotor. By modulating the current through sets of coils sinusoidally with a phase shift of 2 pi over 3, the coils are constantly changing the strength and direction of the magnetic fields they produce. If you look at the graph of current versus time at t equals 0, the green coil's current is 0, and the blue and red are of opposite magnitude, meaning they work together to attract and repel the magnets of the same pole, with magnetic force in the same direction. As the rotor turns clockwise and time goes on, we see how the green coils increase in current and replace the character of the blue coils. Red will soon follow, and the cycle continues. The speed of the motor can be changed with the amplitude and frequency of the current through the coils.
It's important to note that net current will always be 0 in a brushless motor if you only use this basic understanding. Now, saying it like that might not make you realize why this is a problem. But if you think about it in terms of the magnetic field and in terms of the force applied by that magnetic field, what we realize is that if there's always a torque being provided, we know that F is equal to ma, and thus, by providing a constant acceleration, we'll end up reaching an undesired velocity, one that's generally too high. Now, yes, there are things like air friction to balance this out. However, generally, manufacturers do not want to rely on air friction to determine the max RPM of their brushless motor. Thus, current will only run through 2 solenoids at a time in phases, or to prevent a constant acceleration, you can gradually reduce current to 0 and then increase it again. Thank you for watching this video. I hope you learned something today about how physics is actually all around us in our lives.
References: How brushless DC motors work. BLDC and ESC explained. And D. How-to Mechatronics. Retrieved March 16th, 2025 from https://how-it-works/how-brushless-motor and-esc-work/ Tang J. 2021, October 29th. Technical Manual Series. Brushless Motor, Drive Systems, and Motor Torque. Oriental Motor, retrieved March 16th, 2025 from https:// Draken equals FB888-528-958E-4A0D-A350-D6CB4F55 3F75% 7CB22 CFDED BEC 9-42F3 B38C 411AA41AF11.